Consider that you have millions of texts written by humans, and your goal is to generate a new, meaningful paragraph from those texts. You start with 3 words, and then find the most frequent words that appear after these 3 words in sequence, then by randomly selecting one from the top 5 most frequent options. For the next word, you repeat this process using the previous 3 words, and so on. By doing this, you can generate a meaningful paragraph. As the number of words in the context increases, the paragraphs generated become more meaningful. This is Ngram's model. Here you can see that we are using words in a context where their sequence matters. Therefore, we can say that our algorithm is developing some sense of language by understanding how the sequence of words creates meaning, which we can interpret by observing how humans use these words. So, our algorithm is using data to generate a meaningful paragraph. But can we call this machine learning? Now, consider you have a sentence like "capital of France is," and you search these words in your dataset. You get a list of the most frequently used words that follow. The most obvious word is likely to be Paris. You can see that by using an Ngram's model, you have just answered a question. Now, consider a longer question in your dataset, followed by its answer. If you ask the exact same question using an 18-grams model, it will return the exact same answer because it has 18 words in context, and there is a very low chance that you will encounter that exact same question twice. But here's the problem. What if we change one word in the question? Even though the question is almost the same, this Ngram model can't answer it because this exact question might not be present in the dataset. To solve this problem, we use a concept known as approximation using neural networks. Consider the inputs and outputs. Your goal is to provide the answer to the last input using the above data. To do this, you need to understand the function generating this output. This function represents the dataset. However, in real life, we usually don't have the function for our datasets, and they are often very complex. Therefore, we learn that function using the provided dataset using ML algorithm, or we can say neural networks. If the dataset is not accurate, the function cannot be approximated by a neural network accurately. So we can say the function approximation is data dependent. So we should have accurate dataset to develop that function with neural network accurately. Main benefit of this function approximation is that we can predict the output of values that were not present in the dataset. This is a key feature in ML. Consider your goal is to force a neural network to memorize all the outputs of certain inputs. You train a simple model to approximate their outputs, and now, using these inputs as questions, you can get approximate answers from the dataset. It's a bit confusing, but can we say that these 2 weights have essentially memorized the dataset? The memory is in fact storing the dataset within those weights, right? The issue is that to store the information exactly, we would need memory equal to the dataset size, or at least some pattern to store it in a smaller model compared to the dataset. Can we say the same thing about large language models, LLMs? What complex patterns are they approximating from datasets generated by humans? Is it a representation of human intelligence, or is it merely storing data through patterns, creating the illusion of intelligence? Consider you have a neural network that takes the previous 3 words and returns an approximate probability of the next word, and we pick the word with the highest probability. To feed words into the model, we usually convert each word to its embeddings, which are linear vectors representing the meaning of the word. Now, if we train the neural network on 10 words in a context, it can answer a question by predicting the probability of the next word using the given context. Not only that, but its main advantage is that it can answer questions that were not present in the dataset it was trained on. It does this by understanding how similar questions were answered in the dataset. Even though neural networks cannot retain exact information like an Ngram model, they can predict the probabilities of context words that are not in the dataset by leveraging their understanding of the dataset, which Ngram models fail to achieve. Let's train a model to memorize all the data using the next word prediction technique to predict all the next words accurately. However, as we know, the size of the model is not sufficient to learn all the data as it is, so it starts learning some patterns in the data. We discussed earlier that just with two weights, we can learn approximate answers to much larger data by learning the patterns in the data. Similarly, our model will start learning the data by recognizing patterns. But what are the patterns in the data? As humans, we use each word in a sentence according to its meaning to develop some sense. So it is obvious that the patterns the model learns for its embeddings depend on how and in what context the words were used, which is essentially the representation of each word's meaning. So the question is, do these LLMs understand human language?